Hello everyone. So today we'll be learning something new here. So in the last class I've explained you guys about the horizontal irregularities. In this case today I'll be explaining about the vertical irregularity. Vertical means whatever you see here, this is vertical member. So what happens is you guys may have seen some of the places where there will be a parking lot that has a huge height, more than the height of other floors. You guys may have seen that, right? If I'm not wrong. So what happens is that shouldn't be given. Why? Because the stiffness is in whatever the stiffness is there. If the stiffness is less than, like the story drifted, like example, what happens? A story, soft story is a story with whose lateral stiffness is less than the story above. So whatever the stiffness here is, it is less than the ones above. So that is kind of dangerous. What happens is a story, soft story is a story whose lateral stiffness is less than that of a story above. In a building with stiffness irregularity, the following shall be complied with. Dynamic analysis shall be employed. So we should follow the dynamic analysis to capture the actual distribution of lateral stiffness along the height of the building. To capture the lateral stiffness, we need to follow this dynamic analysis method. Okay. And the inner story drift shall be limited to 0.2% in that story, and all the above below. Sorry, all stories below. If any stiffness irregularity. So what happens is the inner story drift is no inner story drift. That means a building with a drift. Drift is like this. So there will be a drift in a building due to the load acting. So what happens? The inter-story drift. Inter-story means whatever the drift happens due to this one. For every flows, there will be a drift, right? So that should be limited to 0.2% of that story. So that is how it works. If any stiffness irregularity also in building with URM, when contribution of masonry infills exceed 20%, if for contribution of masonry, whatever the masonry we place, no example we place masonry here, right? If in the building, if URM infills, when the contribution of masonry infills exceeds 20% in structural plan density of a building, the effect of URM infill shall be considered by explicitly modeling the same in structural analysis. That means what happens is we need to model this walls also. That is what they are trying to tell. If there is a irregularity, okay, and in a building with stiffness irregularity arising out of URM infills, provision 7.9 shall be applied. Okay, this is how it works. So what happens? URM, like unreinforced masonry infills are there, no? Whatever we are going to use, you should be in buildings with unreinforced masonry infills, the contribution of shouldn't exceed 20% in the structural plan density of a building. The effect of URM infill shall be considered explicitly if it is exceeding. If it is exceeding 20%, then effect of URM should be explicitly modeled in the building. So that is how, I mean, whenever you are doing the analysis. So there, these are the two parts. So dynamic analysis should be done. No? The one more thing, inter-story drift shall be limited to 0.2% in the story. If any with stiffness irregularity, we should follow this method. Okay. So this is how it works. Now, mass irregularity, this is something that we should work on. See, what happens is there will be some of the places where, example, in this building right now, imagine there is a heavy mass here. Imagine we are placing a gym, okay? And in this case, if I'm placing a gym, this part, gym, and here if I'm placing maybe library or something like that, okay? Something like that, whatever has a heavy weight. So what do you think will happen? What happens is when the seismic weight at any floor is more than 150% of that floor below. See what happens. The weight here is no, whatever this one is there. When comparing to this one, if the seismic weight is more than this two, like whatever is here it is there, no. See, mass irregularity shall be considered to exist considered to be exist when a seismic weight of any floor is more than 150% of that the floor below. That means whatever the floor here is, example 1.5 into, imagine let's take 25 or something like that. If you multiply this and example this weight to be 50 or something like that, it shouldn't be more than this one. So you should remember that the heavy mass should be more than the weight. Example, if you are placing a gym in here, below that, if there is some kind of structure like rooms or something like that, the mass shouldn't increase. So that is how it works. Like the weight is there, no, whatever is there, that shouldn't increase 1.5 into the above or below structure. Okay, so mass irregularity, that is how it works. So now in a building with mass irregularities and located in seismic zone 2 3 sorry 3 4 and 5, the earthquake effect shall be estimated by dynamic analysis. If there is a mass irregularity, if the zone is 3 4 5, then we need to use we need to follow dynamic analysis method. So that is how it works. Now next is vertical geometric irregularity. What happens is considered to be exist when the horizontal dimension of a lateral force resisting the system in any story is more than 125% of the story below. See, you guys can see this one, no? The area, whatever is there, and the length. You guys can see here that this is like it is reducing, and here it is more. Okay, vertical irregularity happens when the horizontal dimension of the lateral force resisting the system in a story resisting the force is more than L. See, whatever the L is there, no? The total area, if you multiply from here to here, whatever is there, and see what you do is you calculate the whole area out, and whatever the length is there, you calculate the whole length out first. Then what you do, minus this area, you get this one, correct? A. Then what you do, if the area is more than 0.525 L, then it is it is said that it is a vertical geometric irregularity building. So we should be very careful on that basis. Whenever you are building a structure, you should be careful that A shouldn't exceed 0.125 L. And in a building with vertical geometrical irregularity located in seismic zone of 3, 4, and 5, the earthquake effect shall be estimated by dynamic analysis method. So that is how it works. Okay, so example, maybe there is a L-shaped building or something like that. What happens is it depends upon a person who designs it. If an architect is going to design it, it depends on him he's going to design it. So if it is really required, then it is probably we need to design using this dynamic analysis method. So remember that. So it is just like what happens is when a pencil is stacked, like example what happens is if a pencil is stacked on a bigger eraser. So example, this is a eraser, so imagine this is a eraser, and if I'm placing a pencil in here, what happens? So there's an irregularity, right? So this is how it works. So it shouldn't be done. So whatever you see here, this structure is huge and this one is smaller. So it shouldn't be like that. So even in this case also it is the same. Here the area, whatever this part is there, this part is there, and if you compare with the total length, it is huge. So that is how it is. So vertical geometrical irregularity shouldn't be there. If it is there in the 3, 4, 5 seismic zone, then dynamic analysis should be followed. Okay. Next is in-plane discontinuity in vertical elements. So what happens is whenever there is a building, see you guys can see this one, no? There is a irregularity here. The building structure needs to be like this, correct, in a straight line, but it has come out, or they have given a irregularity, there is a irregularity here. If it is a part of a design or something like that, we should be careful about it. So what happens in a plane discontinuity in vertical elements which are resisting lateral force shall be considered to exist when in plane offset of a lateral force resisting elements is greater than 20% of the plane length of those elements. So what happens is first we should know what is the length between this and this. and we need to multiply it by 0.2 LW for whatever the length it is. Okay, and the distance here is there, no? Okay, whatever the distance, when you multiply 0.2 into this one, if it is going to, if this one is more than this, in that case, there is a discontinuity. So you should be very careful on that basis. Okay, so if there is a discontinuity in a building with in-plane discontinuity and located in seismic zone 2, the lateral drift of the building under design lateral force shall be limited to 0.2%. So whenever there is a drift, you should be careful. You should make sure that it should be in 0.2% of a building height. Okay. Building with in-plane discontinuity shall not be permitted in seismic zone 345. See, what are they saying? If this kind of discontinuity is there, it is compulsory that mandate is that it shouldn't be there in zone 345. So you should remember that. Okay. Next is the strength irregularity weak story building. What happens is imagine a building with see, these are the frames. Okay, see, there is something called as the first one that I explained to you guys was a soft story building. Okay, so here what happens, this one is the point, the what is it, the lateral stiffness. Okay, in this case what happens, a weak story is a story whose lateral strength is less than that of a story below. See, here whatever the building you guys can see here, no, it is like this one, this strength is less. Okay, this strength is less than this one. So what happens? The strength mismatches. So there won't be a stiffness possibly. So that is the reason what we need to do. It should be like you should make it uniform. That is a very important thing. And if it is there, the buildings with strength irregularities shall not be permitted. See, it's not permitted. In case the weak story is because of URM, that is unreinforced masonry infills, provision of 7.10 shall be followed. So that is how it works. So you should be very careful. Whatever the clauses they are mentioning, right? You should be very careful about that. You should make sure that we follow this provisions. And normally, what happens is what we normally people suggested, what a structural and suggest is when it comes to earthquake viewpoint of time, viewpoint, it is like whatever zone 3, 4, 5 and all are, it's better not to follow the irregularity thing. We should make sure that it won't be in a irregular shape or something like that. So make sure on that. So in this case, a weak story is a story whose lateral strength is less than the story above. So the same concept with this also. Here also the story is a story whose lateral stiffness is less than the stiffness of the story above. Lateral stiffness comes into picture. Here lateral strength comes into picture. So you should remember that stiffness and strength. There is a huge difference in it. Okay, stiffness and strength. Okay. It is just like if you take an example of rubber band. So what happens with rubber band? It is a material which is strong. If you pull, it will take. I mean, it has a strength to take it, but it is not stiff. It is not. It is not in a proper strong man, or it is not in a fixed shape or something like that. When you pull it, it comes back, or it is strong. So that is how it is. But when it comes to a glass or something like that, imagine a glass, what happens, it is stiff but it is not strong. So that is the difference between strength and stiffness, remember that. So you should be very careful whenever there is any kind of work that is going on. You should make sure that these lateral strength and stiffness needs to be looked at. So these are the two differences. Okay, now, when it comes to floating column is something likely concentrated damage in the structure are undesirable. Okay, a building with floating column shall not be permitted. It is not permitted in any case. If the floating columns are a part of the support, the primary lateral load resisting system. See, what happens? A building with floating columns shall not be permitted if the floating columns are a part of supporting the primary lateral loads. See, primary load resisting system means, in this case, what happens? This column is there. No, this is the one that is distributing the load to this one, correct? And it is a primary part of the lateral load resisting system, and that shouldn't be given. And usually what happens whenever there is a floating column, see, floating column is such a thing that, say example, there is a beam in here and we have given a column this way. So this shouldn't be given, whatever the hanging part is, even here, the example, what happens is, in this case, this is supported by the beam. It is not given that, and it is not connected to the column below. And this is very dangerous. This shouldn't be given. You should be very careful on that. And for the primary loading resisting system, it shouldn't be given at all. So that is how it works. Okay. Next is irregular modes of oscillation in two principles. As I've told you in the horizontal video itself, that the load will be, when the load is acting, there will be three ways how the body will move. One is this way, one is this one is this one, then the rotation. Correct? Then the rotation. So these are the three ways. So what happens is, whenever there is a like oscillation happening, we should be very careful on that. So what happens, the stiffness of the beams column raises, and structural walls determine the lateral stiffness. Correct? It all depends upon the center of mass and center of stiffness. We should be very careful. You guys know that. Okay. A building is said to have lateral irregularity in principal plan direction if a three lateral translation mode contributes less than the 65% of the mass participation factor. So mass participation factor is, so whatever the mass is like participating in the distribution of the load, right? If the first three translation modes contribute less than 65%, that means the first movement is like this, then this one, then this one. So modes contribute less than 65% of mass participation factor in principal plan direction, and the fundamental lateral translation natural period of the building is to in the two principal plan directions are closer to each other by 10% of the larger value. So in that case, a building is said to have lateral irregularity in a principal plan. So you should be very careful on that. We shouldn't make any like building irregular in oscillations, like modes of oscillation shouldn't be followed. So you should remember that. Now what happens, so it is like, imagine holding a tray of center of your finger, and shaking it. Okay, one side tilts and the other one twists, the other one, like what happens, one of them, it will be tilting. So one of the, like, it'll be moving the one or the other side, the other one will twist. So it is the same way. It is just like that. The same way, one will move like this side, one will move this side, and one will rotate. Something, it will twist. So that is how it works. And then what happens is, if you understood what is irregularity, in that case, if the seismic zone is 2, 3, it shall be ensured that first three lateral translation modes together contribute at least 65% mass participation in each principal plan. If the zone is 2 or 3, if the zone is 4 or 5, it shall be ensured that the first three translation modes together contribute at least 65% factor in each principal plan direction, and fundamental lateral translation natural period of the building in two principal plan direction are away from each other by at least 10% of the larger value. What does this mean is, it is like example, there is a building, and how much time it takes for first movement like this, then the other one, and then the rotation. So there are three things, right? First one is to the front, then to the side, then the rotation. So what happens is, it is saying that the time taken, it is like time taken by a building to complete one cycle of lateral sway in a particular direction. So how much time it takes to finish that one cycle, so without torsion. So that is what this means. So we should be very careful. It shouldn't happen. So the fundamental lateral translation natural period of a building in the two principal plan directions are away from each other at least by 10% of the larger value. So whatever is happening, it should cross 10%. it shouldn't be below 10%. So that is what they are trying to tell. Lateral torsional, sorry, translation, natural period. Okay. So if you guys like the video, please do like, share, and subscribe. For more videos, please do subscribe the channel. Yeah, thank you.